A very good afternoon. I'm Mohammad Tahir Ansari, and I'll be presenting my study on the determination of an ideal binder blending parameter. The flow of presentation includes introduction, background, methodology adopted, results, and conclusions. So as we all know that the cost of the highway, constructing a highway is increasing day by day due to the increase in the cost of crude oil and natural aggregates. Therefore, the use of RAP or reclaimed asphalt pavement is a sustainable solution for this problem. The appropriate amount and type of material which we add in the recycle mix is determined using blending charts, and different researchers have used different binder parameters to plot these blending charts. Therefore, there is a need to determine an ideal binder blending parameter based on performance-based tests. So as I mentioned, different researchers have used different binder parameters to plot blending charts, which I have summarized in the form of a table. And for my study, I have used 3 different grades of virgin binder, PG 64, 70, and 76. And PG 76 was considered as the target binder. And this binder was used for synthesizing 2 different types of RAP binders. One of the RAP binder was synthesized using PAV aging, and then other binder was synthesized using oven aging technique. So these RAP binders were then blended with VG 10, VG 30, or the virgin binders, and then the R by T was obtained using the blending charts. These binder blends were then subjected to performance-based tests like MSCR and LAS, and chemical characterization tests like SARA, and based upon the scores, the ideal blending parameter was obtained. So as I mentioned, different properties of the binder was used for plotting blending charts, and I mentioned the 7 binder properties which I have used in my study for plotting these charts. And the R by T from the blending chart was obtained from the point where the target binder value intersects the best fit curve. So from the MSCR test, it was generally observed that most of the binder blends were softer than the target binder, and higher GNR values were obtained. From the LAS test, similar results were obtained, and the blends were showing damage initiation at highest strain levels when compared to the target binder. Similar result was obtained from the complex Morgenstern master curve as well. And the SARA analysis was done to determine the asphaltene to maltene ratio for these binder blends, which was used for giving scores to the binder. So generally, it was observed that the blend which is synthesized using G star into sine delta parameter were having lower GNR and lower fatigue life. However, the fatigue life was comparable with the target binder. A good correlation was obtained between R by T value and the GNR, fatigue life, and the asphaltene to maltene ratio. On a whole, the blend synthesized using G star into sine delta showed better performance when compared to the other parameters, and the blend synthesized using penetration value showed poorest performance, whereas ambiguous results were obtained for 2 sets of data, and good correlation was obtained between R by T, GNR, fatigue life, and the asphaltene to maltene ratio, and most of the blends were softer than the target binder. The results obtained in this study cannot be implemented in the field, and prior asphalt mixture study is needed to verify the results. Thank you.